In recent weeks, troubling rumors have begun circulating among NASA employees. The anticipated mission, which many had been eagerly preparing for, is now shrouded in uncertainty and doubts. What is particularly intriguing is the comparison to a past dramatic mission, well known to all, but now sounding like a warning. Hints of potential emergencies and hidden dangers raise questions about how thoroughly this flight has been prepared. What exactly lies behind these vague hints, and why are scientists so concerned? Could history repeat itself, leaving us with another great challenge for humanity? Subscribe now to uncover the truth behind the rumors and stay informed on the developments that could shape the future of space exploration. Don't miss out. Hit that subscribe button and join us as we unravel the mysteries behind NASA's most intriguing mission yet. NASA has expressed concern about the Boeing Starliner mission, comparing it to the historic Apollo 13 incident. The Boeing Starliner, also known as CST-100, is a new spacecraft designed to transport crew to and from the International Space Station, ISS. It is a crucial part of NASA's commercial program aimed at resuming crewed space flights to American soil following the end of the Space Shuttle program in 2011. Starliner has a capacity of up to 7 astronauts and is equipped with advanced life support and flight control systems. The first test, Orbital Flight Test 1, OFT-1, conducted in December 2019, revealed significant software and flight control system flaws. One key failure was incorrect mission timing, which led to the spacecraft deviating from its planned trajectory by 11 hours and ultimately being unable to dock with the ISS. The investigation into the OFT-1 failure uncovered over 80 issues needing correction. It was necessary to create over 1,000 individual tests, each of which had to confirm that the fixes were working properly, including problems with the user interface and automatic control systems. The spacecraft software, which consists of over 1 million lines of code, required substantial revisions and testing. As a result, the launch of the follow-up test flight OFT-2 was delayed by several months, incurring additional financial and time costs. Another critical issue arose during preparations for OFT-2. In August 2021, just hours before the planned launch, a fault was found in the fuel system valves. 18 out of 24 valves were blocked, necessitating immediate intervention and launch delay. The execution of new tests at all stages of the fuel system involved over 1,000 cycles of opening and closing valves under various pressures and temperatures. This fault led to a mission delay of over 10 months and required additional testing and analysis. Consequently, the OFT-2 launch took place only in July 2022. During these delays, Boeing and NASA conducted numerous tests and equipment modifications. Additional precautions were implemented, including updates to the navigation and communication systems and enhanced quality control of components. The overall cost of addressing technical problems and preparing for retesting amounted to millions of dollars, though the exact sum has not been disclosed. The Crew Flight Test, CFT, is the first mission of the Starliner with astronauts. It launched on June 6, 2024, delivering Suni Williams and Butch Wilmore to the ISS for a scheduled one-week stay. However, Starliner encountered several issues, including the failure of 5 out of 28 propulsion system engines. NASA rescheduled the SpaceX Crew 9 mission from August 18 to September 24 or later, affecting the Starliner return schedule. The issue is also related to the absence of code for autonomous undocking in the current software configuration. In mid-July, NASA reported that it does not plan to use the Crew Dragon spacecraft to return the Boeing Starliner crew from the ISS to Earth. By late July, the agency acknowledged that the crew and the spacecraft will remain at the ISS until at least August, as the mission has been suspended. The success of the Crew Flight Test, CFT, which will be Starliner's first crewed flight, hinges on addressing all identified issues and successfully completing all tests. NASA and Boeing continue to work closely to avoid a repeat of the Apollo 13 situation. NASA scientists warned that neglecting identified technical issues could lead to serious accidents and endanger crew safety. This criticism became particularly sharp after the OFT-1 incident, where over 80 issues were identified, and subsequent problems with fuel valves during the preparation for OFT-2. NASA, with its extensive experience in crewed missions, expressed serious concerns about the Boeing Starliner's readiness for safe flight. The primary aspect of the criticism was the spacecraft's software. OFT-1 revealed several serious programming errors that could have had catastrophic consequences. NASA insisted that every line of code needed to be reviewed and tested in various scenarios to prevent similar failures. There have been instances where seemingly minor errors led to fatal outcomes in space missions. NASA emphasized that even the slightest malfunction in these systems could result in catastrophic outcomes. In the harsh environment of space, where every detail plays a critical role, such uncertainty is unacceptable. And safety concerns were not limited to technical aspects alone. Experts also expressed worries about project management and quality control. Why were some of these issues not detected until the very TT moment? The physical structure of the spacecraft was another important aspect. NASA identified potential weak points in the design that might not withstand the stresses of launch and landing. For example, one component of the hull showed insufficient resilience during overload simulations, which could lead to its failure at a critical moment. The navigation and communication systems also came under close scrutiny. Given that the Starliner will operate in high radiation environments and various space factors, it was crucial that all sensors and communication systems functioned flawlessly. All possible external and internal factors that could impact the mission's outcome needed to be considered. In preparation for OFT-2, NASA and Boeing conducted numerous tests and software updates. These measures included rechecking over 1 million lines of code and simulating various flight scenarios. However, even after these efforts, software problems continued to arise. For example, ground tests revealed failures in the control system that could lead to incorrect spacecraft orientation in space. One of the most critical aspects was the interaction of software with the navigation system. Star trackers used to determine the spacecraft's position can be affected by cosmic radiation. As a result, the software must be capable of correctly interpreting data and timely adjusting the flight trajectory. Any failures in this system could lead to significant deviations and even loss of control of the spacecraft. NASA has also expressed concern about potential cyber attacks. In the context of modern cyber warfare, protecting spacecraft software from hacking and unauthorized access is critically important. Boeing and NASA have implemented additional security measures, including data encryption and enhanced control system protection. The issue of software reliability remains a key concern for the Starliner mission. The situation is compounded by the fact that the spacecraft has already faced these problems in space. Recent orbital incidents have underscored the need for continued work on the software and additional precautions. Video conferences and statements by NASA and Boeing experts regularly highlight the importance of this issue and the commitment to ensuring mission safety. Integration of various systems and components of the spacecraft raised serious concerns among NASA specialists. The complexity of the Boeing Starliner project lay not only in the individual components, but also in their interaction in the space environment. Improper integration could lead to systemic failures, which could be fatal for the mission and crew. One of the key aspects of integration was the interaction between the flight control system and the navigation and propulsion systems. During preparations for OFT-2, it was found that synchronization between these systems did not always work correctly. Specifically, it was discovered that data transmission delays between systems could reach up to 500 milliseconds, which is critically important during high-speed flight and complex maneuvers. The integration of the power plant also presented a complex challenge. The fuel system, including tanks, valves, and engines, needed to operate in perfect synchronization to ensure stable and safe flight. The communication and navigation system, including star sensors, GPS, and radio communication systems, also needed to work in full synchronization to ensure precise positioning and data transmission. Ground tests revealed that under high cosmic radiation and solar flare conditions, sensors could provide false data. requiring immediate correction. Integration issues also concerned the modular design of the spacecraft. The Starliner consists of several modules, each performing its own functions. These modules must connect and interact seamlessly to ensure overall spacecraft functionality. Tests revealed that mechanical connections between modules could fail under changing temperature conditions, potentially leading to air leaks and other critical issues. The temperature in the thermal chambers should range from 100 to 150 degrees Celsius to ensure the reliability of the life support system. NASA strongly recommended that Boeing conduct additional tests and checks of all systems and components. It is crucial to identify and resolve current issues and anticipate potential ones that might arise in real spaceflight conditions. Minor integration failures on the ground could turn into disasters in space, so attention to detail and thorough testing are key factors for mission success. Will Boeing manage to resolve all integration issues and return the crew to Earth? The comparison of the Boeing Starliner mission with Apollo 13 highlights potential risks and underscores the importance of thorough preparation and testing. The Apollo 13 incident, which occurred in April 1970, was one of the most dramatic moments in the history of spaceflight. An oxygen tank exploded on the way to the moon, leading to the loss of electricity and life support systems. Thanks to the heroic efforts of the crew and ground team, the mission ended with a successful return to Earth, but not without significant risk and tension. The Apollo 13 crew demonstrated incredible resourcefulness and determination, which helped avoid tragedy. For the Starliner mission, NASA developed intensive training for astronauts, including simulations of various emergency situations. This included modeling failures of life support systems, navigation systems, and other critical components. Nevertheless, despite all these efforts, the astronauts sent to the ISS continue to remain in space, facing the consequences of ongoing issues. Ensuring their safety and the successful completion of the mission requires prompt resolution of software and spacecraft system obstacles. NASA and Boeing are working on fixing identified defects and conducting additional tests to ensure the highest possible safety for the crew. A key task remains preparing for potential unforeseen situations and improving the reliability of all systems to ensure the successful return of the astronauts to Earth. The financial aspect also plays a significant role. The cost of the Apollo 13 mission in 1970 was around $375 million, which, accounting for inflation, is approximately $2.5 billion today. Problems with the Boeing Starliner have already led to significant cost overruns. Each delay and each additional check adds millions of dollars to the overall cost of the program. It is also important to consider that the Apollo 13 mission demonstrated the value of international cooperation and support. In the context of modern globalization, the Starliner project could also benefit from collaboration with international partners, allowing for the use of a broad range of knowledge and technologies. Ultimately, the comparison with Apollo 13 highlights the importance of not only technical readiness, but also of psychological preparation of the teams. The success of the Starliner mission depends on many factors. The measures taken and additional testing play a crucial role in ensuring the safety of the astronauts and the successful completion of the mission. The Boeing Starliner mission requires synergy between engineers, scientists, and managers from both organizations to effectively address issues. One key aspect of this collaboration is the prompt response to identified problems. During the preparation for previous test flights, both OFT-1 and OFT-2, numerous issues and failures were detected. Thanks to joint efforts, many of these were successfully resolved, allowing the project to move forward. Additionally, both parties must pay special attention to details and not overlook even the slightest deviations. Every technical decision, software update, and test must undergo strict control and verification. The exchange of information and experience between NASA and Boeing will enable quicker identification and resolution of problems, as well as more informed decision-making. This is especially important given the constraints of time and resources. The collaborative work on the Starliner project demonstrates that achieving set goals is possible only through coordinated teamwork. The successful completion of the mission will serve as a prime example of how cooperation and attention to detail can overcome any challenges. The crew that will remain on the ISS for the coming months continues to work actively, maintaining high mission standards and making a significant contribution to its successful completion. Subscribe to the channel and follow the news to stay updated on all developments and achievements in the Boeing Starliner project and other space missions. Stay tuned so you don't miss out on when the crew returns to Earth. The exact date is still unknown, but we promise it will be exciting.